Hey there, awesome physics students. Let's do a static equilibrium example that includes both forces and torques in our analysis. Now, one of the key features that you're going to see in this is where do you put the gravitational force? The gravitational force acts at the center of mass. While we're working this problem, it's important for you to keep in mind that what you're trying to learn here is not the exact details to get everything correct all the time. What you're trying to learn is the procedure, the process for doing this. How do you build this up? That's what you want to take away with you, because we're always going to make little mistakes. I make them all the time, and that's not going to stop. But the process is what you want to take away. Okay, so let's talk about the example. We have a person that's laying on a plank. The plank is a length of 2 meters. The person has a height of 1.6 meters. The person's feet are flush with the bottom of the plank. So there's a little headspace up here. The plank is supported by 2 scales. One scale reads 380 newtons, and the other scale reads 440 newtons. So this scale supports more weight than the other one. Now the question, we know the mass of the plank is 6 kilograms. The thing we don't know is the mass of the person and the position of their center of mass. So that's what we want to find. We want to find the person's mass and their position of the person's center of mass. So how are we going to do this? Well, a key feature in static equilibrium problems is that there's no acceleration. And so this tells us the total force on the system will be 0 in any direction. The other key part is that there's no angular acceleration about any axis. So because of that, the sum of the torques about any axis will be 0. One of the first things we need to do in a situation like this when solving this is draw the free body diagram with all the forces acting where the forces act. So these scale forces are already drawn where they act. Now we just need to draw the other forces on this. So there's the weight of the plank that points down, and that's going to act at the center of mass of the plank, which is in the middle here. So that's going to be right there. That's the mass of the plank times g. And then the other force that hasn't been drawn yet is the weight of the person. And so that's going to act at their center of mass. Now, I don't know where their center of mass is. You're like, where do I draw that? But what you do is you just pick a point on your drawing, it doesn't matter where, and draw the center of mass. And then you label the weight mg. Now, we don't know m, but we just give it a variable name, m, and then that's going to enter into our equations and we'll be able to solve for it. Similarly, we don't know where to put it, but let's just give the center of mass position a variable name, x, and that will come into our torque equations and we'll be able to solve for it, okay? All right, so I think this is all the forces on there. Next step is to adopt a coordinate system. So I want to use a standard XY coordinate system for this. There's no reason to do anything different. The other thing I want to do is select a positive convention for torque. I see no reason to deviate from the counterclockwise positive convention for torque, so let's do that. All right, it's a little less intimidating to get started with the forces, so let's do those first. Let's sum the forces in the y direction. There's no forces in the x direction, so there's no point in doing that. The forces in the y direction will be this positive 380 Newton force, this positive 440 Newton force. We'll have the mass of the plank down. That's negative because it's down. And we have mg, which is also down. That's our unknown force here. And those are the 4 forces. So I set those equal to 0. Now, why do I set those equal to 0? Again, the acceleration is 0. I set this equal to ma, but a is 0. All right. So if I look at this equation, I notice I know all these. I know that. I don't know the mass of the person. That's the only thing I don't know. This is one equation, one unknown. I can solve that. So let's go ahead and do it. I'll move the mg to the other side. And this gives me mg equals 380 plus 440 is 820 newtons. And then I subtract off the mass of the plank times g. And I know the mass of the plank is 6. I could plug that in now, but let me just write it this way so you can see what I'm doing. I want to solve for m, so let me just divide both sides by g, so that gets rid of the g, gets rid of the g, and I'm left with just the mass. So if I take this, now I know all these, I can just plug all my numbers in. And if I do that, if I plug those numbers in, I get 77.7 kilograms. Okay, so the person's mass is 77 kilograms, so I know that. So now the only thing I need to do is find the position of their center of mass. For that, I'm going to need torque. The forces are not going to give me that information. When I sum the forces, the distances did not come into play. When I do the torques, they will. Okay, so I want to sum the torques to find this. I need to choose an axis of rotation. I'm going to choose their feet. The reason I'm going to do that is because the center of mass is the variable that we've assigned is given from the feet. And so I want to find that if I put it there, that will come into the equation straight away. I could use this, the top of the plank, but then that would, the distance there to where their weight acts would be 2 minus x, and that's just, it's okay, but it's just a little bit more complicated than just putting x. So I want to sum the torques about their feet. So I'm going to put the axis of rotation there. It's always a good idea to label the axis of rotation, especially when you sum the torques. Always put that down there. All right, so let's go force by force. I'm going to get a torque from this force. That's 380 Newton force. And I'm going to use, for this, I'm going to use torque is equal to RF sine theta. So the R vector goes from the axis to where the force acts. That's 2 meters. And the force vector points up at 380 newtons. And the angle between those two is 90 degrees, so the sine is sine of 90. And then I need to decide, is that positive or negative according to our convention? Well, if this is the axis, this is going to make it rotate like that, which is clockwise. Clockwise is negative, so I need to put a negative sign here by hand. Okay? All right, let's go. We've got that one. Let's go to this one. That's the distance there. The R vector goes from here to here, and that's 1 meter exactly. So that's 1 meter. Then the force is a mass of the plank times g. That's 6 kilograms times 9.8 newtons per kilogram. And that is then the angle between those two is 90 degrees, so I'm going to have sine of 90 there. And that is going to, about this point, that's going to cause rotation like this, which is counterclockwise and therefore positive. So I'm going to put a positive outside that. And then the next torque I want to consider is the mass of the person. This one I don't know, but I'm just going to use the distance there is, the R vector goes from the axis to where the force acts, that's x. That we don't know. So this is how x is entering to our equation here. And then m, the force is mg, but I know that it's 77.7 kilograms times g is 9.8 newtons per kilogram. And then the angle between those two is 90 degrees again, so I'm going to have sine 90. And about this point, that's going to cause counterclockwise rotations, so it's going to be positive. And then my last torque is going to be from this 440 Newton force. But because the R vector goes from here to here, R is 0. In other words, this 440 Newton force does not cause any kind of change in rotations about that point, right? That makes sense. It's not going to cause it to, rotate around there. So it's the torque from that is 0. So that one is 0. I'll just put plus 0 there, but you can leave it off if you want. Okay, so now let me just take inventory here. I know all these, I know everything except x. So I have one equation. I haven't set this equal to anything yet. Because alpha is equal to 0, the sum of the torques will be 0. Okay, so now I have an equation. And I have one unknown, so I can solve this. So I just need to solve this for x. Now I'm going to drop all the sine 90. They're just 1. Let's go ahead and I'm going to take this term, and what I'm going to do is I'm going to take this term and throw it on the other side, and this term and throw it on the other side. And so this term becomes x times 77. I'm going to drop the units to times 9.8 equals, this becomes, when I throw this on the other side, it becomes positive. So this is 2 times 380 plus this term here, which is going to be 1 times 6 times 9.8. And when I throw that on the other side, it becomes negative. Okay, so now I just need to divide both sides by this 77.7 times 9.8. And that gives us x is equal to, and I'll write this out so you can see, it's kind of messy here. This is 2 times 380 minus 1 times 6 times 9.8 divided by 77.7 times 9.8. And when I punch that into my calculator, I get 0.92 meters. Okay, so their center, this tells me, I need to interpret this. This tells me that the center of mass is 0.92 meters from their feet, right? So that would be, if they're standing up, center of mass would be about a meter, 92 centimeters above their feet. Okay, so hopefully this helps you understand how we do these. There is a process you want to follow and understand the process. It's common to make mistakes. Don't worry too much about those mistakes while you're learning the process. That's inevitable, and I continue to make mistakes even though I've done this many, many times. All right,